A Gaussian or normal distribution is a symmetrical bell-shaped probability distribution where most data points cluster around the mean. Many natural phenomena like human height, weight, body temperature, etc. tend to follow a Gaussian distribution. We in this lecture will talk about Gaussian distribution, also called normal distribution or bell curve. Gaussian distribution is given by where fx is the Gaussian or normal distribution, x is the variable, sigma is the standard deviation given by where mu is the mean or average of the data values and n is the total number of data points. Standard deviation refers to the spread out of the data around the mean or average, that is, the distribution f of x shows how much do the values x differ from the average mu. If we plot the data, that is the variables x along x-axis and fx along y-axis, we get a curve that has the shape of a bell. This curve is called Gaussian or normal distribution. The curve is symmetrical. Most values will cluster around the average mu and few values will be farther from the average, leading to a bell-shaped curve. Not all distributions are bell-shaped, some are. Now, normal distribution and histogram are closely related. Suppose we consider heights of, say, 15-year-old boys from a city. A few will be very short, a few will be very tall, but most will be somewhere near the average, say around 175 centimeter. A histogram is a visual summary of the raw x values. It shows how frequently values occur in different ranges, which we call bins. If the data follows a normal distribution, then histogram will look like bell-shaped, symmetric, highest in the middle, tapering smoothly on both sides. Normal distribution is a theoretical smooth curve arising out of a mathematical model. The histogram is empirical, based on actual raw real data. The normal curve is a theoretical plot based on average mu and standard deviation sigma. We can compare the two by plotting a normal curve over a histogram. If histogram matches the bell-shaped curve, then the data is normally distributed. Histogram shows actual distribution, shows peaks, skewness. Normal Gaussian curve shows expected shape. It is easy to analyze mathematically and it helps in probability calculations. A histogram does not automatically mean the data is normal. We must check symmetry. For normal distribution, it is a perfect symmetry, no leaning left or right. We must also check if there is a single peak, the tail extension. For normal distribution, the tail is long and thin and is asymptotic and symmetric. We should also check the skewness. For normal distribution, skewness is 0.